Welcome back. This is our final video for lesson 20. So in this video, we're going to see how to get the domain and the range of a quadratic function just from looking at its graph. So let's look at example 7 from that worksheet for lesson 20. So here we have the graph of a quadratic function with vertex 3, 1. And the question asks us to find the domain and range of the function, and to write our answer as inequalities in each answer, using x or y as appropriate. So first of all, the domain. Remember, the domain is all the possible x values or x coordinates of the points on the graph. And so when we look at this graph, we see that it goes on forever in the horizontal direction to the left and to the right. That's what the blue curve with the arrows at the end, it means it goes on forever upward, but also it keeps getting wider and wider. So it's going to take all possible x values. Okay, it's going to go through every possible x value. So that means we don't have to write it as an inequality. We can just say the domain is all real numbers, or all reals. And now remember, the range is the set of all possible y coordinates, or second coordinates of all those points on that parabola. Now we see that there's a minimum point, there's a lowest point, that's called the vertex, and the coordinates are 3, 1. So the lowest y coordinate on that parabola is 1. So we can see that the function has a minimum value of y equals 1, and it goes upward forever and ever, and it never ever stops going upward. So that means there's no actual maximum value. There's no maximum y value, or no maximum value of the function. So that means it goes on forever upward, and the lowest possible y coordinate is 1. So we can write that as an inequality: y is greater than or equal to 1. So that's the range. Let's look at another example, number 8. In this one, the parabola is opening downward, and so its vertex, which has the coordinates -1, -2, that vertex is the highest point on the graph. So we're asked for the domain first, that the domain is all possible x coordinates. And once again, we can see it goes on forever off to the right and off to the left. In fact, that's true of all quadratic functions. The domain is always all real numbers. You can plug in any x value you want into a quadratic function. But the range, we can see that, like I said, there was a highest point. The highest point is the vertex, -1, -2. And so the range is all possible second coordinates, or y coordinates, of this function. So we can see that there is a maximum value. That maximum value is -2. The highest possible y coordinate is -2. It's at the vertex. And all the other values are less than that. All the other y coordinates are less than that one. So there's actually no minimum value. So we can write the range of this function as an inequality: y is less than or equal to -2. So in the first example, we had a minimum, or the vertex was the lowest point, so the range was y greater than or equal to some number. But in this one, we have a highest point. So in this one, the range is y is less than or equal to some number. Okay, so that's it for lesson 20, and you will begin lesson 21 in class.